This right here, consider a uniform hoop of radius r and a mass and rolling without slipping, which is larger, it's translational kinetic energy or it's rotational kinetic energy. And I think it's
both are the same.
Yeah, both are equal. I put rotational kinetic energy is larger, but I'm just confused, I guess, between the two.
Okay, so let's look at it. So we have a hoop, right? So our hoop, okay, so we have kinetic energy, so we have like translational, right?
Yeah.
That's just our 1/2 mv squared is translational.
That's translational?
Yep.
Okay.
And then our rotational, that's the 1/2 moment of inertia times angular velocity squared.
Okay.
Okay, so what we want to do is we want to like compare the two to see how they relate.
Yeah.
So we're basically going to get this in terms of mass and velocity
Okay.
to see how what it is. So okay, so the moment of inertia for a hoop is mr squared,
Okay.
right?
Yeah.
And then, okay, so angular velocity is going to be v over, so velocity over like radius.
Okay.
So we're going to plug those guys in for this. So we have our 1/2, our moment of inertia, mr squared, angular velocity. And since it's squared, we're going to square each term.
Oh, yeah.
So we have like v squared and r squared, right?
Yeah. Okay.
Well, so you'll notice radius is on the bottom here and top here. So you can cancel the radius. So rotational kinetic energy ends up being 1/2 mass times velocity squared. So it ended up being the same thing
Yeah.
for a hoop.
Okay.
Yeah. If this were something else, like if this were a solid disk, this moment of inertia would be 1/2 mr squared. And so this would end up being like 1/4 mv squared.
Okay.
So it wouldn't end up being the same thing. But for a hoop, it ends up being the same thing.
Yeah. All right.
Yeah.
Makes sense.
Yep.